All right, so the third and final objective of this week's work. So objective 3 says, I can find the axis of symmetry for a quadratic function from factored form. So you should have already completed this part 1 investigating parabolas. It's on Desmos. I created it myself, but it's a pretty cool activity for you to look at before you do this video. So go ahead, and if you haven't done investigating parabolas, stop this video, go and do it, and then come back, because it will really give you an better understanding of what I'm about to talk about. So part 2, how does the axis of symmetry compare to the x-intercepts? So we've talked about, or you'll see in this class, 3 different forms of quadratic functions. Or rather, there are 3 different forms of quadratic functions. We will focus on the first 2. So we are really just concerned with this standard form and factored form. Vertex form you'll talk about in Math 2 next year. But for now, standard form we've talked about already. You've seen it last week. F of x equals ax squared plus bx plus c, where remember that a cannot equal to 0. Factored form is what we're about to focus on. It writes the quadratic equation into 2 different factors. What I've left off of this is there really should be an a value there that will talk about its effect next unit. But for now, factored form is the product of 2 things because they are the factors of standard forms. They're all connected. You can get between them, and that's what you'll do in Math 2. So let's look at how factored form works. So using this graph of this function, so the function is f of x equals x plus 6 x times x minus 4, and I've graphed it over here at the right. So it says, what are the x-intercepts of this graph? So I know my x-intercepts are negative 6, 0, and 4, 0. How do you see the x-intercepts in the equation? Well, I can see that I have a plus 6 here, and then a minus 6 here, and then I have a minus 4 here and a 4 here. So my x-intercepts are really the numbers from the equation with opposite signs. So it's actually the opposite pair of the numbers in the equation. Okay. Then it says to find the midpoint of the x-intercepts. So remember that midpoint is the middle. So you find the average of the 2 numbers. So you do negative 6 plus 4, and then you divide by 2. So negative 6 plus 4 is negative 2 divided by 2 is equal to negative 1. Where do we see the midpoint on our graph? Well, when I look over here, I see that midpoint at negative 1 right there, and that corresponds to the axis of symmetry. So that point is called the vertex, but the specific x value of the vertex is the axis of symmetry. So it appears in the vertex. What is the axis of symmetry, and how does this compare to the midpoint of the x-intercepts? So I see that my axis of symmetry is that vertical line down the middle, and that negative 1 is so my axis of symmetry, my AOS, is x equals negative 1. So the axis of symmetry is x equals negative 1, which is the midpoint of the x-intercepts. We can see on the graph that the vertex is negative 1, negative 25. How can we use the fact that the axis of symmetry is x equals negative 1 to find the rest of the vertex algebraically, so without using our graph? So if you remember, we have this function equation, right? We know that f of x is equal to x plus 6 times x minus 4. If we know the x value, we know we can always find the output by plugging in what x is to get out what y is. So I can find f of negative 1 by saying negative 1 plus 6 times negative 1 minus 4. So f of negative 1 will be negative 1 plus 6 is 5. Negative 1 minus 4 is negative 5. So f of negative 1 is negative 25, which was the y value of our vertex. So all we need to do is plug in our x value to find y. So let's fill in these blanks. The x-intercepts from the equation in the form f of x equals x minus h times x minus k, aka factored form, are h and k. So they're the positive version because it's the opposite pair. To find them, just change the signs of the values in the parentheses. The axis of symmetry is the midpoint of the x-intercepts. In fact, the axis of symmetry is actually the midpoint of any 2 points on the graph that have corresponding y values. And that's because the axis of symmetry cuts the graph in half. So it's that line of symmetry, so it's the reflecting point, so everything on the left will correspond to something on the right. So as long as they have the same y value, then they'll also be, the axis of symmetry will be the midpoint of them. But the x-intercepts are the easiest to find, which is why we use them. Since the axis of symmetry is the x value of the vertex, if you want to find the rest of the vertex, all you would have to do is substitute the value of the axis of symmetry into the function for every x value that you see. So you would just plug it in and simplify. So here are your steps. In order to find the axis of symmetry when given the x-intercepts, you follow these steps. 1, you find the x-intercepts of the function. 2, you find the midpoint of the x-intercepts using that midpoint formula, which I have highlighted here for you. Then you'll write the axis of symmetry as x equals the answer from step 2. Then, to find the vertex, you plug the axis of symmetry into the function for x and simplify. So let's do example 1 together here. So it says find the x-intercepts, then find the axis of symmetry. And actually, I forgot to add in that you also need to find the vertex. So our x-intercept, we want to use the opposite value of the two numbers here. So since this is negative 5, the x-intercept will be positive 5, 0. Since it's a positive 3, it'll then be negative 3, 0. To find the axis of symmetry, you're going to find the midpoint of your two x-intercepts. So we're going to do 5 plus negative 3 and divide that by 2. 5 plus negative 3 is 2. Divided by 2 will give me 1. So my axis of symmetry is x equals 1. Then I want to find the rest of my vertex. So I'm just going to plug my x equals 1 in for x in both factors. So I'm going to have, let me change this to there. So I'm going to have 1 minus 5 times 1 plus 3, and that will equal y. So 1 minus 5 is negative 4. 1 plus 3 is 4. So y is negative 16. So my full vertex is 1, negative 16. And it's as simple as that. Let's do number 2, just for some extra practice. So the first thing I want to do is find my x-intercepts. So I remember that I want the opposite pair of the two numbers in the parentheses. So it'll be negative 2, 0 and negative 6, 0. Then I find my axis of symmetry by finding the midpoint of those. So negative 2 plus negative 6 divided by 2 is negative 8 divided by 2 is negative 4. So my axis of symmetry is x equals negative 4. Finally, I find my vertex by plugging negative 4 into my x's. So y will equal negative 4 plus 2 times negative 4 plus 6. So y will equal negative 2 times 2, which is negative 4. So my vertex is negative 4, negative 4. Now, take a few seconds or a few minutes and do numbers 3 and 4 on your own and check back. The answers for 3 and 4, so you can go ahead and check your work. Remember that sometimes when you add and divide by 2, it doesn't go evenly, so it's okay to have a 4.5 as an axis of symmetry. Now go to Canvas and complete the practice finding axis of symmetry from x-intercepts.